Yeah. So good morning, everyone. I would
Good morning,
like
sir. Once
to,
again.
I would like to
Yes, sir.
begin my session. So once again, thanks for inviting me for giving this, sharing my understanding about this, and I'm also looking forward for a lot of comments and suggestions from your side based on this particular session. So I'll begin by sharing my screen. So I hope you are now able to see my screen. Are you able to see my screen? I just want to confirm before I begin. Hello.
Sir, your screen is visible, sir.
Okay. So I just wanted to confirm that. Okay, so I am right now on the first
Okay.
slide, that is IoT applications in electric vehicles. So this is the work done. So a part of this, maybe about 30-40% of this work done by my student who is recently graduated his MTech. Whereas the remaining work I am right now presently doing with my other students and some of the material collected from the various sources. So now just to introduce you to the topic, I want to begin with one picture. In fact, most of my slides are going to be filled with pictures because since this is a keynote address, I wanted to make the concepts. I want to keep the talk at the level of concepts with little bit of technical ideas. So this is a picture that you are seeing on the screen where you have vehicles parked under the carport, where the shelter of this vehicles has a solar panel. So immediately we can see a natural application here, that whatever solar power you generate can be used to charge the vehicles if they are the electric vehicles. So right now they may not all be electric vehicles, but then eventually electric vehicles, as we hope, will become more prominent. Now, how to operate this particular system? Because this in itself is like a small electrical system where there is a supply and there is a demand and there is a connectivity to grid and all these kind of things is there. So this is one of the uh, uh, problem that we will be studying. Okay, so this is a brief outline of the talk. So consider it as like a Venn diagram. So where one particular diagram or one particular circle is pertaining to Internet of Things, and the other one is pertaining to electric vehicles. Okay, and then there is an intersection where the IoT and electric vehicles come into picture. So we will go step by step in all of this. Okay. So first I would like to briefly talk about the electric vehicles part. Okay. So when we started looking at these electric vehicles, some of the literature survey we had carried out, and we identified usually what are the problems or what are the concepts here. So first look from the grid perspective. So from the grid perspective, load regulation, road regulation with voltage and overload constraints, and maximizing the operational efficiency. So in the presence of electric vehicles, looking from the grid operator perspective, that means the distribution operator perspective, how this load regulation or the maximization of efficiency can be done. So this is one. Next one is aggregator perspective. Now what is this aggregator? So aggregator is the person who provides the electric vehicle charging facilities in this context. That means an aggregator may have at a particular strategic location, may have lot of EV charging slots or EV charging stations, where just like how a vehicle goes to a petrol station or a gas station and fills it, similarly these vehicles come to the aggregator and fills it. So that is one. Also the aggregator can need not be physically at one location. The aggregator can virtually aggregate the electric vehicles in a particular geographical region. So that is also there. So how to manage that? So we found some work in the literature on that. Then electric vehicles user perspective. So now as a owner of electric vehicle, what I can do? So first one is the provision of ancillary service. We found something, and that means I am providing service to the grid. Similarly, charging fairness. So what should be the electric vehicle, the charge and all, and then minimizing the battery degradation. So how to minimize my battery degradation? This is another issue. Now earlier what I showed is the operational aspects. Now in this slide related to cost. So from the grid perspective, minimization of cost of power operations and minimization of grid operator revenue. So these are some of the terms. And from the aggregator's perspective, so maximizing the aggregator profit. That means, let's say you are the owner of a parking lot with charging stations. How do you maximize the profit? So what happens here is the electric vehicle purchases power from the aggregator. Aggregator in turn purchases power from the grid. So what price the aggregator is purchasing from the grid and what price the aggregator is selling to the electric vehicle. So through the difference of that price, there is a scope for increasing the profit. But meanwhile, since the electric vehicle is actually a vehicle and it can move, if you charge too high value, then the electric vehicle may go to the another aggregator. So you cannot, you need to maintain some balance there. So such kind of problem, we found some work in the literature. Then EV user's perspective. So minimizing the EV charging cost. So as a user, how do I minimize the charging cost? So at what time should I charge? What is the appropriate time and all such kind of topics. Okay. So let us again, since I said it is going to be a broad keynote session, so let's talk about some of the roles that are there in the picture. So first one is the role of the researcher. I kept researcher as the first one because I come from the role of the researcher. So where we analyze the data and we analyze the present situation and then do some kind of research output, so suggesting some solutions and all. Meanwhile, the second one is the owner. So owner is very important. The owner of the infrastructure. So for example, charging station, whatever, like I mentioned. So that one. And next one is the investor. So why should anybody invest in a infrastructure for supporting electric vehicles? So what is the motivation for investment? So that is another thing that we need to think about. Next, we have grid operator. So eventually, see, right now the electrical grid does not have any electric vehicle load. I mean, not a significant amount. But eventually, as electric vehicles become more prominent, a new class of loading will fall onto the electrical grid. Almost, it may even double the total consumption from the electrical grid, because the whole transportation energy now has to be routed through electrical grid, whereas the earlier transportation energy was like using the fossil fuels and all. There the electricity grid did not get affected because of the transportation demand. But now the transportation electrical demand will also fall on the grid, and therefore the grid operator role becomes very important. How to operate the grid such that there are no overloads in the system, and the grid technical parameters are maintained, like voltages and frequency and the stability and things like that. Next, we have the driver. Now we need to make this thing convenient for the driver. That means if I have usually in the electric vehicle parlance, the term used is the distance anxiety, which means what happens if my electric vehicle loses the charge on the road in between. So then how do I find the nearest charging station? So the whole ecosystem has to be developed in such a way that this kind of distance anxiety is addressed, and not only that, we need to make everything convenient for the user. So we are going to discuss that concept later, that plug and play, how it can be made easy for the driver and the user. And finally, the services. So when some problem occurs or when some new kind of service is needed, so all that service definitions and everything, what kind of support is needed, all that is also another role. Okay. Now as a person that you are watching this lesson or this lecture, you can come with any role. So maybe you are the driver of the electric vehicle, or maybe you are the researcher, or maybe you are the investor, owner, or the grid operator, or the service provider. So from the your different role, your perspective will change. So that's why I wanted to highlight some of this. Now I would like to discuss some concepts related to electric vehicles on this. So again I am mentioning, I am not going in depth right now. I am just briefly giving you overview of the subject of electric vehicles, and eventually towards the end of this session I will discuss one or two case studies. So there we can actually see some of these simulations that we have run and all. Okay, so coming to these concepts. So the first one is demand response. So what is demand response? The demand response is in the electrical power language. The demand response means the demand has to respond. So usually what is the attitude is the demand will not respond. That is the previous the thought that whenever I switch on the light, I want light, and whenever I want, I can control my demand. Whereas the supply has to respond to the demand. But now the thinking is changed. Depending on the supply, the demand will have to respond. So in other words, so for example, when to charge your electric vehicle. So when the solar power is excess, only at the time you charge the electric vehicle. So like that, if you define some kind of concept, then it's called demand response. So one area of study is how demand response can be implemented or applicable for electric vehicles. Next, benefit maximization of parking lot owner. So benefit maximization of parking lot owner, already we just briefly mentioned that if you are the owner of a parking lot, how do you maximize your profit? Distribution system operator perspective. So when distribution system operator schedules the operation of the grid, which means even before 24 hours for the next day, the distribution system operator will predict what is going to be the demand on the grid. Accordingly, the distribution system operator has to arrange the supply side. He has to purchase the power at different values of power at different times in the day ahead market to meet the forecasted demand. Now all of a sudden, if the electric vehicles come into picture, then the distribution system operation becomes a little bit tricky. So that is one more concept. Next concept you should know is what is called as vehicular energy network. In fact, this is again an interesting topic. If you search in any of the journals, you will also find a good number of papers on this topic. What is vehicular energy network? Vehicular energy network is nothing but you are actually using the vehicles as your energy network. So in other words, let's say there is a remote village, and the remote rural area, that remote village is almost like 100 kilometers away from the nearest city, and that in that remote village you would like to provide the electricity. Now one way to provide electricity is you have a vehicle, a truck filled with batteries. So the truck will get charged in the night time in the city, and early morning the truck will go to the village, that remote location, and there the truck will the energy stored in the truck will be supplied to the local houses and places in the village, and in the night the truck returns back, and then again it charges, again it goes into the next day. So this is like a, see why we are doing, like why not simply construct a power transmission system. So again the distance is like 100 kilometers and it's a remote location, the transmission system may become too costly. So to avoid that cost, this is another way, delivering the energy through vehicles. This is the vehicular energy network concept. Now this idea may seem something new or maybe something radical, but actually there are so many this kind of ideas. So if you look at the generator van, which is very famous, so if there are any functions or any marriages or anything like that, eventually there will be a generator van there. So of course it is supplied by diesel, but it is actually a kind of a energy generator on a vehicle, on a wheels. So similar concept we can apply for vehicle energy networks. Next, using electric vehicles on road for energy delivery. So this is again a similar concept, EVs on road for energy delivery. Next is frequency regulation by EV. Now if it's a weak grid like a microgrid and all, and the frequency of that needs to be controlled to improve the stability and all, under emergency situations you can use the energy stored in the electric vehicles to regulate the frequency. So that is another concept. Then electric vehicles as virtual power plants for grid support. So this is again another area. So where you have a virtual power plant concept, that means there is no power plant, but if let's say if you aggregate 100 vehicles and control their output, so together these 100 electric vehicles can work like a virtual power plant. Again, how to make it enabled. So this is one more concept. Then coming to last one, of course this is a very big list. I just to the extent what we could find, some of the things I have listed in this. So selection of electric vehicle charging station. This is another problem. So what happens is, let's say in a city there are 10 charging stations. One is at one location, 5 kilometers away another charging station, another charging, here and there their charging stations are located. Now the electric vehicle on the road now has a choice whether to go to station 1, station 2, station 3, station 4, because not always you go to the nearest station, because if you have sufficient charge and you want to charge it optimally, you may try to find, even if it is little far, you may try to find a charging station which has a lower price, because this I mentioned this 10 different charging stations, they are competing with each other to get the electric vehicle customer. So this is another kind of selection of EV charging station. This is another problem. So just like there are so many apps like Uber or Ola for cab booking services, in future you are going to find apps for identifying nearest charging station and purchasing the power and things like that. So all that things comes under that concept. Okay, so data. So let me briefly mention this data and then I will pause for some doubts. So first is data is very important. Data is needed for electric vehicle analysis. So what kind of data we are talking about? The first one is electric vehicle energy supply data, electric vehicle energy demand data. So when I mean supply data, the electric vehicle can have a bidirectional power flow. So it can supply the power and it can receive the power. So that's why that data. Now the electric vehicles are moving on the road. So road network data is needed. But then the electric vehicles are connected to the power grid. Therefore power network data is needed. So here the road network and power network have to be simulated together. So in some kind of a co-simulation model. Now load curve with and without EV. So this is again, it is expected that when the entire electric vehicles demand falls on the grid, the load curve may even double. So that danger is there. So we need to monitor that. We need to keep smart meters to monitor this. And then forecasting of the grid load or solar load or EV load, and events and disasters at the city level, and also of course the time of the day prices, at what time you should charge, at what time you should discharge, all these things. So it's like, again, as one of the earlier speakers have mentioned, this is a truly interdisciplinary work where the electric vehicle means that the transportation department, civil engineering department, those researchers will come into picture, and electrical people will come into picture, chemistry and the battery, chemical, those people, and again the software, and again the economics. So many interdisciplinary concepts are coming into picture. Now at this stage I would like to briefly take a minute, and I would like some of the participants to express if they have any doubts or any queries. Then again we will continue with the further talk. So any questions, any doubts right now? So I'd like to keep the session a little bit interactive. So that's why I would like to give an opportunity for members to raise some questions that comes to their mind. So please feel free to use this time to ask any question that that comes to your mind. Need not be a specific one. I would definitely want to receive at least one question. So I'm just briefly reviewing the presentation. Okay, so apparently there seems to be no question at this moment, so it's fine. We will always have time to discuss further. So let me now continue with this presentation. So in this slide, I would once again summarize whatever we have done before. So on the left side top, here you can find the demand response, benefit maximization, whatever concepts we just now discussed. On the right side is the information. So to implement any of these concepts, so for example, to implement demand response, you would like to know what is the load curve, what is the forecast, when the peak power is coming, and things like that. So this information is required to implement this particular concept. Now down the roles I already mentioned: planner, owner, user, investor, operator. And on the left side I have shown the physical system. So the grid is the one physical concept: rooftop PV, charging station, electric vehicles, residential prosumers, industrial prosumers, and distributed storage. So this I briefly like a summary. So again, feel free to stop me in between if you have any question, so that I'll get a sense of how this content is delivered. Okay. That was just a brief overview of electric vehicles. Now coming to, of course, by definition, whatever I have done is very limited. So much work is going on in electric vehicles. So I always invite you to further explore and find more information. Now coming to Internet of Things, again I don't want to, because we are all from electrical engineering background, I don't want to spend more time, maybe just 2-3 minutes just discussing what is this Internet of Things. So instead of explaining it in any other way, I thought this picture was quite interesting. So here, image source, I got this image from one of the Google search. So this is the image credit. So but then broadly this picture, I liked it. It summarizes what is the Internet of Things. So obviously you can see the connectivity. Okay. So for example, let's start from here. Okay. So a light bulb is there. So a light bulb is connected to things. So all our things in our everyday life, we interact with so many things. All these things can be connected to internet. Then what happens? So this concept is called Internet of Things. Is it useful? Is it beneficial? Yes, of course. There are a lot of applications, lot of services is possible. So just in the interest of this picture, I would like to mention. See, for example, this electrical bulb is connected to the internet. So what is the benefit of it? Now, normally we say if you switch off the light when you leave the room and things like that. But now, because if the lamp is connected to the internet, through some kind of intelligent programming, we can control the lights, we can switch off the lights. When we detect that there are no people in the room, automatically lights can be switched off. So automation kind of thing. So a TV can be connected to the internet. So obviously now the smart TVs are coming with internet connectivity, so that you can watch online videos, not just the regular TV channels. Telephone connected to the internet, nothing to explain there. The entire telecom, already know. Now iron box connected to the internet. What is the purpose of connecting iron box to the internet? So maybe again it has some benefit in terms of monitoring the consumption, how much you are using, and things like that. And also maybe you can control the iron box through internet, through some kind of pressing programs and things like that. So for different types of clothes, different materials and things like that. Now is there anything more interesting? Yeah, here you can see on the right there is a weighing machine. So people can check their weight. Now that weighing machine also connected to internet. So why to connect a weighing machine to internet? So every day you check your weight, you look at the weight and you forget. But if you connect to internet, it may store the data, and then through some apps and all, you get access to the data. You can plot how your weight is varying over the years. So 2020 is considered to be a different kind of year because of the COVID-19 situation. But then one of the parameters, how people's weight has been changing because of this working from home, things like that. So that is again an interesting thing to study, but having IoT will help in that. So IoT for your plants, whether the plants are watered or not, so that internet can take care of it. So IoT for your webcam, IoT for your bathtub. So let's say what is the temperature in your water in your bathtub, at what time you plan to take bath, all the things. IoT for your appliances like fans. This is smart dustbin concept. Even the dustbin has internet connection, because when the dustbin is filled, it can send a message, and a automated truck can come and empty the dustbin. So like this, anything and everything can be connected to the internet. So for example, here you can see a washing machine, I believe this one, and aeroplane is connected, cars are connected. By the way, cars connected, that is what is today's subject, so we are going to discuss that further. So with this brief idea, even cycle is connected to internet. So why cycle needs to be connected to internet? So again, you can go for GPS tracking. So you can track your how much cycling you have done, how much kilometers you traveled, and things like that. And also later, when your cycle is stolen, again through internet connectivity you can find not only cycle, all the stolen objects can be tracked through IoT. So any item is stolen, immediately you can look its location and then go to it. So here I use pictures. Here I'll just simply use the words. I got this definition from Wikipedia. So IoT describes a network of physical objects which are called things that are embedded with sensors, software and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. So two objects will be exchanging information. So there are so many benefits and applications for it. Now for example, these are very broad areas. So medical and healthcare, smart home, banking and finance, telecom, transport, water, smart cities, electrical grid. You can also say some manufacturing plant, smart manufacturing plant, factory, and some control systems. So many applications are there. So for this particular IoT. So I think with that brief talk about IoT, now I would like to come for IoTs for electric vehicles. So again, I would like to pause here. Any questions, any doubts you have so far? Please feel free to ask right now. Yeah, so again, let's continue. If there are no questions as of now, we'll continue. Now, I would like to just take a overview of how this EV charging can be delivered as a service. So in this case, we are assuming that the electric vehicle is connected to getting the power from a charging station. Charging station in turn gets power from the grid. So what you see down here, so this thick line is the physical electrical flow of the power. Meanwhile, the grid is available at different places. So I have shown there may be a different other electrical supply, so of different companies. So this electrical charging will become a kind of a business, and many companies will set up their EV charging stations. So just now, like we have different companies setting up petrol stations and diesel stations. Similarly, EV charging stations by different companies. Now, there is a need for all these to communicate with each other. Why? Because let's say this particular electric vehicle has a contract with a particular company, and that company may have multiple stations. So wherever you go, you should be able to charge your vehicle because you have a running contract with one particular company. So in other words, let's say ATMs. So you have a bank account in one bank. Now they will give you the debit card, and throughout the city there are multiple ATMs. Anywhere you go and use the cash machine or ATM and download or withdraw the cash from the machine. So in the similar concept, an electric vehicle owner can have a contract with a particular company, like analogous to a bank, and they can use their services across the city. But what happens if you go to a different company? So a different company may set up a charging station. Does that mean that you cannot charge there? So again, going back to our ATM example, if I have a SBI bank ATM, sorry, the debit card, can I withdraw cash from Union Bank or any other bank? So again, the answer is yes. So even though your bank is different company, the owner of the bank is different, still you can withdraw money from a different company's ATM card. So how is it possible? It is possible because of the standardization of your debit card across the companies, and also there is a between companies there is a communication. So here also I showed that, see, this blue color charging station considered as one particular company, whereas this red color charging station may be a different company, but still the customer of this may go to the charging station of the other one. Then how much is the contract, what is the this thing, that has to be communicated between these two separate companies. Just like I mentioned the banks as an example, also take another example. Let's say the telecom service providers. We have, for example, Airtel, and we have Jio, and we have BSNL. So multiple telecom service providers are there. Is it that only Airtel customer can talk to Airtel customer? No. Airtel customer can talk to Jio customer or BSNL customer, because the individual companies again are in communication. So that problem will arise, it has already arisen, and it has to be addressed for future proliferation of electric vehicles. So I hope you are now getting the understanding of the problem. Now how this problem can be addressed? There has to be a central service for scheduling of your what you call the contracts of your electric vehicle. So let's say banks also have a central clearing this thing. So if I use a debit card of one bank and then go to the ATM of another bank, through that central banking clearing house, this information is shared with across the other banks. So similarly for electric vehicles also such kind of thing. So obviously without Internet of Things we cannot make that happen. So meanwhile, distribution system operator I have shown here. Again we discussed this earlier. What is the status of the grid? Which part of the grid has excess power? Which part of the grid is overloaded? So all that information, if it is provided to the central service or to the individual charging stations, accordingly you can utilize the resources available at the charging stations to help the grid. So this is what we are calling as demand response. So even for that, there some kind of communication has to be required, and it has to be standardized. Now we come to the topic of standards for electric vehicles. So without standards, these things are not possible. So same way the standards are helping people to withdraw money from different ATMs. So because the debit card is standardized, irrespective of where you are in the world, which country you are and which company you are and all, the same debit card will work across the world. Okay? So that is because of standardization. Therefore we now come to the topic of standardization. Okay? So before I'm sorry, I just have to mention this slide also, and then we'll go to the about standardization. So what we are calling, this is like a imaginary or this kind of a dream kind of thing. Some places this dream is already been realized, but majority of places this is not yet done. That is vehicle to grid in plug and play model. See, right, what is plug and play? See, right now we have mouse and keyboard. They are very much plug and play. You can just purchase any mouse and then just connect it, and it starts working through the USB port. It starts working on any computer. So I can take my mouse and keyboard, connect it to a different machine, and there also it works. So similarly, the electric vehicle charging also should become plug and play. What do I mean by plug and play? The first step. So this is a step-by-step process. So step number 1, the user plugs in the electric vehicle at the charging station. Immediately, a TCP/IP based communication will start using the PLC technology on the same wire. See, this wire which is connecting to, just ignore this plug because it's just a icon. So the wire continues and then goes to the vehicle, and then this is the charging port for the vehicle. Now, not only for carrying the electrical energy, this wire is also used for carrying information. What kind of information? So it will begin a TCP/IP based communication. So for TCP/IP based communication, you need some kind of a controller or some kind of a machine or a system in the electric vehicle also. So in future, all the electric vehicles will come with that particular circuit or chip which can communicate over internet. So that will become an integral part. Okay? Now next, authentication and authorization. Now what is this authentication and authorization? See, if I connect the electric vehicle, immediately whose electric vehicle it is. It has to be linked to a particular user, it has to be linked to a particular owner or user of the electric vehicle, and it has to be authenticated. So the authentication can also be done through this particular plug and play system. And what is this authorization? Authorization means even though the authentication is there, authorization also needs to be there. So for example, let's say my friend takes my car, electric car, and wants to charge, but the car is original, like it's a real car, but then I have to authorize him to charge. So the authorization part comes there, or I can even disable. So for example, my electric vehicle got stolen. So if the vehicle got stolen, I can remotely or through whatever means, if I can stop the electric vehicle from getting charged, then it becomes useless. So this is one application for the step 3, that is authentication and authorization. Now step 4, begin charging session. Now what happens in a charging session? So that's what is there in the next 4 steps. First thing is sharing of the electric vehicle status information. So what we are supposed to do, the moment you plug in the electric vehicle will identify itself, authenticate and authorize, and then start sending some information first. Even before any electrical energy is passed, information is passed through the same wire, through PLC. Okay. So what is information? What is the present stage of charge? What is the arrival time? At what time I plan to depart from parking lot? at the time of departure, how much charge I want to get it, whether I want to optimize on the cost or not. So all this electric vehicle related information must be provided. Next, discover the services. Now, meanwhile, from the charging station side, multiple services can be offered. So it need not be just charging of the vehicle. It could be even discharging of electric vehicle. It could be some frequency regulation service. It could be some voltage control service. So demand response. So variety of services are available, going to be available at the service station. What kind of services are available, this vehicle should know. And then it has to select a service and define a contract. Yes, I am interested in this particular service. I want my car to be charged, and for charging this much, this is my contract. This much will be the financial, payment details and all. So that contract has to be formed. Next, step 8, scheduling and delivering the service. Now the service is defined, but then the moment you connect need not charge, because at that instant the price may be high, and if the departure time is sufficiently long, then you can properly schedule the vehicle. So that's what happens here in step number 8, scheduling and delivering the service. Now at 9, ending the charging session. And then these are all self-explanatory. Step 10, billing and payment. Step 11, TCP/IP based communication will be ending. And step 12, we unplug the electric vehicle. So everything happens through this just plugging and playing. So there is no need to see, for example, authentication, authorization. It can happen through this particular wire itself, without the need of logging into your app in your phone, getting the OTP, specifying the OTP, giving the banking details. See, all the things can be avoided by properly, this is basically kind of a dream, properly designing a plug and play system where all over the world it is standardized. Wherever you go, it's the same plug and play. Just plug in, and then automatically only you will be billed, only your consumption will be monitored, and service will be provided like this. So I hope I made it clear what is plug and play here. Okay. Now we stressed enough about standards in the last to enable this kind of service and this kind of plug-in capability. Definitely standards are needed. Already 2 standards I showed on the screen. So first, these are the international standards defining a vehicle to grid communication interface for bidirectional charging or discharging of electric vehicles. So these are 2 standards organizations. ISO is a international standards organization, and IEC is International Electrotechnical Committee. So under the ISO 15118 is the standard number pertaining to road vehicles, vehicle to grid communication interface. Another standard is IEC 61851, electric vehicle conductive charging system. So like this we found a couple of standards also. So again, before I move forward, any questions from any participant? Yeah, so let me again continue. So modes of charging. See, if you now go into this standardization, in this standard which I mentioned 61851, they have defined the modes of charging, and these are very interesting and important from the perspective of policy and designing regulations. Okay, so especially it's important in India. So let's discuss what it is. Right now these modes are defined for worldwide, not specific to India, but let's look at this. There are 4 modes of charging. So this is 1, 2, 3, 4. So first I'll go to mode 1 charging. Now this is very simple. No communication, no protection, just use the plug from the home. No EV monitoring, prohibited in many countries. So because this kind of thing can cause a lot of issues. See what kind of issues? See what basically the solution is, you have the electric vehicle and you have this charging wire. Simply plug in the charging wire to the plug point in the house, and automatically your electric vehicle will start getting charged. So what is the issue? It's very good thing is it is very simple, but then there is no communication between the, so we don't know when the charge is full. We don't know what is the intention of the electric vehicle. He wants to charge or discharge. So all these kind of things, no issue or no consideration for no consideration for time of the day pricing, etc. So this is mode 1. But here protection also not there. Sometimes overheating may happen. So all these things. So that is the reason. In fact, metering is also not there. So there will be a meter here. Say at the point of connection of grid to the home, here there will be a main meter. Now this electric vehicle will be data is coming under this main meter, but specifically for electric vehicle there is no meter. Okay. So that's why even grid cannot differentiate what is the load is coming from the electric vehicle and what load comes from the other appliances. This is about mode 1. Now coming to mode 2, what they have done is only change is in this particular cable there is a small box. Using that box they are doing control and protection. So just this is a small device installed in the particular charging that cable. So it takes action of controlling and protection. So which means there will be some kind of sensors in this box, and they will monitor how much current, how much voltage, how much temperatures, and based on that they will be used for controlling. So as you know, now from mode 1 to mode 2 we have become slightly more challenged coming towards the real world implementation. Now coming to mode 3. So mode 3 already we discussed in earlier context, but now in the context of this communication. So communication EV charging station dedicated for EV, communication enabled, standards compliant, and EV metering and inbuilt protection. So even you can meter the EV and you can define a inbuilt protection system. So these are some of this is a slightly better version than the model 2. Now coming to mode 4, here it is quite different. So dedicated EV charging stations, output is DC, no wonder for onboard converter, no need for onboard converter, communication enabled, standards compliant, and EV metering inbuilt protection. So these are the features of this mode 4. Okay. See here main thing what is happening is the AC to DC conversion is happening, and DC fast charging can happen. Okay. These are the 4 modes. And also in the literature we found that people are talking about levels of charging. So let us clarify this topic also. So the first level, the charging from 120 volt AC standard household outlet, takes long time for charging, suitable for overnight charging. So if your charging demand is very high, it may take entire overnight for charging. So again it's not that this method cannot be used, but this has its limitations. Next, coming to level 2, charging from 240 volts AC plug, specialized equipment need to be installed, takes 4 to 6 hours for charging. So instead of 120 volt AC plug, you need 240 volts AC plug. Now coming to level 3, charging at 480 volt DC, also called as DC fast charging, and it charges almost 80% of the battery in 30 minutes. Okay, so this is level 3 charging. So again these are some of the terminologies. You don't have to remember everything. They just have level 1, level 2, level 3 for charging. Okay. So now again I would like to just briefly show about what is the work we are doing in our lab at IIT Hyderabad. Any questions as of now? Okay, so if you have no further questions, let me continue. So some ongoing work at IIT Hyderabad. So I would like to discuss this. So now here you can see a large diagram. let me control the view. Okay, anyway, so I think I'll use this to explain. So what we are trying to do here is, imagine that there is a grid at the right, okay, at the extreme right, there is a grid, and the grid power is coming down, and there is a energy meter. So this energy meter is for the entire apartment building. It will monitor what is the demand. Now from there, the power goes to different apartment buildings through some kind of this switches, parallel circuits and things like that. And this star mark indicates the metering point. So each apartment building, each flat is now power is metered. Now all these meters are reporting to building energy management system, which is a software system. In this diagram, this orange color box, it is a software system, and it is reading the data from the daily consumption of the apartment building. Therefore, this building energy management system can interact with the grid or through EV aggregator. We'll come to this. Meanwhile, come here, there is another star here. So this star is going all the way to the left corner and then splitting into 4 stars, EV, EV, EV and EV. So here what is happening, the apartment building in the basement, they have a electricity panel. So from the panel they can take in correction for one of the meters, and then they use this setup for creating a electric vehicle parking lot. So here we have 4 parking lots. So what is the information exchange? So I mentioned that some information through PLC and all is being exchanged. So let's look at the output of EV. So EV information, so car ID, SOC, SOCH, arrival time, departure time and so on. So this kind of EV information will be available. Meanwhile, discharging and charging command. So that command can be given by EV aggregator. And then EV power flow data. So again, power flow data, you know, when all these appliances are into grid, it becomes a whole bigger grid, and we need to operate it. Now what are the, here I mentioned EV aggregator. What is this EV aggregator? EV aggregator is the person who collects all the data from the EV and processes it, and then specifies it in BMS in such a way that the information can be useful. So in this case, the amount of DR is mentioned, car ID is mentioned, charging command, discharging command is mentioned, then EV information, all these things are mentioned. Now what are the objectives? Reduce the bill of homeowners, reduce the bill of buildings, emergency support to buildings, EV power out profit, EV battery degradation, cost benefit analysis. So these are some of the goals. So shall I move to the next one? So the next slide, instead of here apartment building, now we change to a commercial building, where how we are going to do it. So commercial building typically doesn't have this IoT Hyderabad storage containers. So anyway, so the right side part is very similar, whereas now the left side part, what we are saying is a bidirectional electric vehicle. It may happen that in a commercial building, the power may be too high, maybe 8 rupees or 10 rupees. So in order for saving that money, the electric vehicle can charge in the night time, go to the mall, and then directly connect the this system in the mall. So EV will charge at home, residential tariff 3 AM to 5 AM. EV will drive to commercial building, and EV will discharge at commercial tariff, example 6 to 8 rupees. So this is about this particular concept. Okay. So we have just started working on this, so not much of progress is done on this, but then I thought since anyway this is an interesting session, so I have to, even though it's not published, even though it is not fully, results are not yet obtained, we thought I'll share it. Okay, so any questions up to here? Okay, so if there are no further questions, I'll once again continue. Next, I would like to talk about a case study. So, let me see, I heard some sound, whether anything in the chat. Okay, so I think I'll go back. Alright, so now we come to case study. I just try to briefly present the findings of master's thesis on EV scheduling. Okay. So as I mentioned again, Mr. Praneeth, he is right now working in General Electric in Hyderabad. So this is his previous year's MTech work. Okay. So problem definition: scheduling of electric vehicle charging for the benefit of charging stations. So this is the first objective, and electric vehicle as demand response provider. This is another objective. So again, in the overall concept map, which concepts are applicable, those things I have shown it in the blue color. So for example, electric vehicles on roads not required, vehicular energy network still not required, road network data, power network data. So some of the things they are not required. I mean, they can be studied, but for this case study which I am going to discuss, they are not required. So here it is like this. So architecture for implementation of charging station demand response management system, CS-DRMS algorithm. So this is the one of the contributions by that particular student. So let us try to understand this. So essentially, this particular charging station demand response management system is kind of a software. So we have simulated and we have implemented this in a software. So what happens? So the CS-DRMS, so this is what is our important like algorithm where we are implementing. Now what happens? We from the vehicles we will get the vehicle data, and from the CRMS we will get the vehicles charging and discharging schedule. So this is rooftop solar car charging station. Anyway, next, time of use and demand response tariff. So according to time of use, these two will keep buying and selling powers to each other. So this is while that is going on. Meanwhile, the utility grid has to carry the power to the system. So this is about charging, for the one case. So just the same algorithm, little bit more detail. I'm just showing you a small flow chart. So left side top we have solar data input. In between we have electric vehicle owner input, and then electric vehicle detection point. So these are some of the inputs. Then given these inputs, I am calculating SOC required at the departure based on baseline, and finding, see on the other hand, from the solar data, finding charging load per hour. So each hour what is the charging load. So that information we can extract from this on the other side. Next, coming to this one, check for the low price. When the prices are low, only then it will move forward. Okay. So here also same thing, only when it moves forward when the prices are low. See, finding cars available for discharging and required to charge the number of hours to charge or discharge controller. Find out amount of charge to be discharged per hour. So I am just briefly reading this. Anyway, so again, lot of this is self-explanatory. You can pause the video and study for yourself. Let me go to the next slide. So there are two types are taken. So two types of case studies. So the first one is vehicular battery capacity is 24 kilowatt hour and mileage is 0.3 kilowatt hour per kilowatt. Whereas type 2, vehicle's battery capacity is considered slightly more, 30 kilowatt hour, and mileage is 0.4 kilowatt. I'm sorry, I think, yeah. So total number of charges selected in the parking 50, simulation time interval 15 minutes, total number of cars 450. So like this we have taken the data. So this is the input data, arrival time of the cars. So the left figure, this one is arrival time of the car. So it goes, sometimes the cars are arriving early in the morning, sometimes they are arriving late in the night, and then finally they stick to the daily routine. And total number of cars based on departure time. So different cars are leaving at different times, so that also can be monitored. Next we have this plots like this, wherein I have mentioned the car ID and required charge at the time of departure. See, what happens is every car comes to the parking station, and in this data we are having 450 cars, 0 to 450 cars, and the car may have excess energy and it wants to discharge its power, or the car may have less energy, and so therefore on the spot it wants to purchase from the market. So here is where the bargaining and market clearing will happen. And then if you see any car, if you take either it is charging car or discharging car, and accordingly the schedule has been made. Now another topic we come to here is demand response. So in the demand response, what we are doing is that the demand response requires support by the grid and support provided by charging station. It's not the other way around. Charging stations are not asking for demand from the DSOs. So DSO has to reply. So here if you see, in steps it is increasing. Yeah, so what we can see here is the demand response requested and then discharging energy supplied to the grid. So here I can see how much is the demand. So where there is a deviation, there is a energy supplied to the grid. So that we can see. Now if the charging station also has solar, it is better. If the charging station has solar and wind, then it is even better. And then solar generated with demand response capability, that is even better. Yeah, sorry. So now let's continue. Time of the use pricing. So this I just showed some cars data, input data, and then also some the demand response request data. So based on this, the time of price also is there, time of use is pricing. So look at the electric vehicles selling to the grid. So time of use buying from the grid, selling from the grid, and so basically selling by the grid and buying by the grid, because this middle one has to be charging station to EV owner. I think there is some mismatch in the legend, but it's okay. So at different times different prices are there. So that's what I wanted to mention. So go to the when you go for the cost comparisons. So again I provide the reference to this paper in the end, but in the interest of time I just want to show only the results. So first what we have. So without the solar and without demand response, uncoordinated. So how much revenue the earned by the parking lot owner? So that is 13,355. On the other hand, cost was 11,471, and therefore the savings is 1,884. Now coming to without solar and with demand response coordinated. So at least you have demand response. So because of that, so the revenue kind of remained same, but cost have improved significantly. Next, coming to solar power now. So you have solar power and now you also have a solar battery. So therefore your result must be much less than the others, but then here it is more or less showing the same because demand response is not considered. Now again look at the table, it is self-explanatory. The costs are going on reducing and then savings are going on increasing. So in fact the last case with solar and with DR, so instead of 20,000 revenue, but the parking lot owner also getting a profit of 10,000. So finally, what are the learnings from EV scheduling? So propose an algorithm for charging station demand response management for scheduling of charging and discharging of vehicles. Then cars available for discharge are used for providing demand response support to utility. And finally, the last observation. By using cars available for discharging, it is possible to reduce the peak load curve of charging station, and that can be achieved. So based on this, we have one paper in IEEE ISAP conference, Intelligent System Applications to Power System. So by the way, I am just come to the end of the slide. So I have some references and publication. So with this, I'll once again pause for the questions. We have more about 10 minutes time. So since I was counting the time for the questions that are going to be asked, so I wanted to keep some time in the end. Yeah. So now over to the audience again. So if you have any questions, feel free to ask these questions.
So thank you, sir. One common question for the benefit of audience, sir.
Yeah.
Sir, during charging, you have given car ID and some you have considered almost 450 cars during charging. You have shown some graphs also, sir.
Yes, yes.
Sir, is there any recording of the time taken for complete charging or car ID? And, yes, sir.
So actually, I think I skipped one or two slides here. So here you can see. Again, the case study is the same 450 cars, but not all the cars are present at the same time. Okay, so here x-axis is not actually hours, it is a time blocks. Okay, so a day is divided into 15-minute time blocks, so 0 to 96 time blocks, and then the number of cars arriving in each time block, that is marked here. So the cars are arriving and the cars are departure. So on the right there is a departure also. So it's like a continuous flow of cars, arrivals and departures. So from that we are trying to establish what is the load curve. Yeah. And then here we can see charge required and then discharge at the time of departure. So charging and discharging we can see. I hope that answers the question.
Yes, sir. Yes, sir. Sir, approximately how many kilometers can we travel, sir, for full charging? Is there any case study, sir, related to that?
Yeah. So what? Of course, we have done everything simulation.
Okay,
but then if you look at the electric vehicles available in the market, even in India, so I think at least the vehicles that are right now available has a range of 100 to 150 kilometers, and abroad the much more range is there, almost 300 above kilometers range is there.
Okay, sir. So in your point of view, how much time it takes to have the electric vehicles in Indian market, sir? Full flex, a replacement of these petrol or diesel cars. How much time it takes, sir?
So I am expecting at least the change is going to be like kind of sudden. So for some time it will be slowly gradual, but then suddenly once it picks up, then immediately everything changes. So in fact there is one video I saw. They shown the picture of New York. So there is in New York City there is one road they showed, and on that road, this is a very black and white photo, early 19th century, like 1910, 19 something like that. So at that time they were using lot of this horse. Huh?
Okay, sir. Thank you, sir. Yes, sir. Yes, sir.
So they were using horse carriage things. Majority 99% of the vehicles are all horse driven vehicles. Then immediately within 5-6 years they replaced with everyone has a diesel car. So why suddenly it shifted means maintaining a horse is more costly than maintaining a diesel car. Now the moment the maintaining diesel car becomes more costly than the electric vehicle, then immediately people will switch over to electric vehicle. So maybe as early as next 5 years we can see very good amount of electric vehicles in India also on road. I hope that answers the question.
Yes, sir. Thank you, sir. Any questions from participants? So, Dr. Pradeep sir has a lot of expertise. The participants can interact. So even for the general related questions also, sir will answer for 5 minutes. Right. So at present, if there are no questions from the participants.
So I have a question. So
Yes,
since now we are conducting this particular HTTP program, so ultimately your objective is to get back into encourage research in this area, right?
Yes, sir.
What are your future plans on this? Are you looking for some kind of anybody is interested or scheduled to do some work on this? I just want to know because there might be multiple colleges involved. Does any college have this charging facility, charging infrastructure, any kind of ongoing work? Can anybody update? It will be interesting.
Okay. But this is the recent area I have maximum the recent research scholars who have started their research work recently. They may look into all these issues, sir, because this is emerging technology.
Yeah.
Definitely will expect a lot of work in future also.
Okay. So that's it from my side. If there are any questions, feel free to email me and we can continue the discussion later. Yes.
Okay, sir. Right. As of at present, if there are no questions, you can also contact sir through our phone or through email. Okay, sir will respond for our questions. Okay. So if there are no questions, let me conclude today morning session, keynote session, and on behalf of the VVIT management, principal sir and IEEE department, I would like to thank Dr. Pradeep sir for accepting our invitation and sharing his knowledge to all and electrical engineers. So, he has started with the basic concepts and overview and its applications of IoT applications to electric vehicles. Okay, as divided into this presentation into 3 parts. So, the concepts related to electric vehicles and data need for electrical vehicles and analysis. Then IoT overview, concepts and applications of IoT, general applications to medical and this transportation of electric vehicles, and the correlation of IoT and EV charging services and the vehicle to grid, and some standards for electric vehicles, ISO and IEC standards has been discussed, and the different modes of charging also includes. And apart from all this, some ongoing work on these electric vehicles at especially at IIT Hyderabad has been discussed for the benefit of all the participants. I hope all these issues will be useful for your further research work, and I personally thank you once again, Pradeep sir, for sharing your knowledge to all my participants in the STTP. So thank you, sir. I will get back to you, and sir.
I'm sorry, I'd like to briefly show something.
Sir.
I want to share the, since we have a couple of more minutes time.
Yes, sir. Yes, sir.
Sorry. So we at IIT Hyderabad there is a new MTech program on smart mobility. Just this semester only it started. So this is a MTech program with the specialization in smart mobility. So you can go to this link, and here you can find the I'm sorry, you can find the brochure, some details about how to apply and things like that, and also the course curriculum and course structure and all is also there. So eventually, even at the all India level, there are more and more institutes are starting a MTech program in electromobility. So I just want to inform that. Yeah. So you can just search like this, MTech program on smart mobility, IIT Hyderabad. You will find this link. This is for your information.
Thank you, sir. Thank you. So thank you very much, sir. Pradeep, sir. I will get back to you.
Yeah, thank you.
A small announcement for all the. Thank you, sir. Thank you, Pradeep, sir, once again. And a small announcement for